So we're going to continue our discussion on kind of looking at radioactivity. So when we start talking about radioactivity, there are kind of a couple things. We're going to talk about the types of radioactivity, the types of radiation, but kind of before we get to that, we want to start talking about the cause of radioactivity and the cause of radiation. And really, it essentially boils down to one primary cause. And that cause is that there's an unstable nucleus. And so the question that comes from that then is, well, what makes the nucleus stable? What makes it unstable? And so if you remember, when we think about the nucleus, so we've got protons, and we also have neutrons. And so that right there, representation of a helium atom, its nucleus, 2 protons, 2 neutrons. And so there are actually 3 forces that are going on between these protons and neutrons. And so one, as we've talked about, you have strong forces holding them together. But we also have electromagnetic repulsion, making these positive charges want to push away from each other. So pushing protons apart. And there's one third kind of factor and force that's going on with that. And something I don't think we've talked about a lot yet, but is that's purely the kinetic motion. Both the protons and the neutrons. And so when we talk about this kinetic motion, all that we're talking about there is like for any specific. So 1 proton. Just looking at just one. So we've got 2 of them here, but we're going to look at just one. That proton isn't sitting there stationary, just not moving at all. That proton is basically kind of moving all around, and how much it moves depends on the temperature. But it might be, so if it's with a bunch of other atoms, especially with the strong forces kind of holding them together, then it's bigger and it has a larger mass. But if we're looking at, say, just 1 proton, like what we might see with hydrogen, well, that is hydrogen. And so this is going to be moving. It's a kind of a combination. Is that it has a tendency to want to move on its own, just kind of wherever it might want to go. But then also, if it's lumped together with other particles, so this movement's based on temperature and the energy. Higher the temperature, more energy, faster it's moving. But in addition to its tendency and its desire to just move all around and bounce everywhere, if it's with this other proton, so you have a proton here and a proton here, and then we just go ahead and add in these 2 neutrons. These 2 protons even though like we've kind of represented being side to side, and these strong forces are holding them together, they're not just sitting there. They're based with, if you were to zoom in with a super powerful microscope, you would see that they're vibrating kind of in this direction, and then they also kind of vibrate like this. So you get movement. So you get movement in this direction, kind of like this, and you also get movement, I mean, essentially kind of really it's in all three directions, or all three planes. And so moving this way, and then kind of up and down, and kind of in all those different directions. And so you have these two atoms that are kind of, like if you were to zoom in, you would see the two protons. You would see the two protons kind of doing something like this, with that representative of that kinetic energy. And so you have the strong forces trying to push them together and hold them together. You have this electromagnetic repulsion trying to push them off. And then you also have this kinetic energy. And so when the strong forces overpower the other two, then the protons stay together and it's stable. When this electromagnetic repulsion and this kinetic motion are greater than the strong forces, and it comes apart, and that's radioactive decay.